Hi everyone and welcome to this new series of tutorial. In these videos we are going to learn how to make several types of wire netting. Each of these videos will have a different approach to make the final result, so let's get started with the type 1. I'm in Blender version 3.3.0, delete collection standard, camera and light. Go to plus, general and geometry nodes, shift A to add the mesh and add a simple plane, press new button. So the concept is create a vertical line and horizontal line with the shape of sine equation to cross each other along a grid that we will create next. So I have to create a single curved line, shift alt and click to isolate the selection. This is our line. Go with 1 to the front orthographic view, and we have to manipulate this line with a sine shape. So first of all, resample curve. We can start with 100 counts, and then we have to set the position of the points. Then we will have to convert this curve to mesh using a circle curve with the fill caps and a radius of, you can imagine in the real space, 0.003 meters, 3 millimeters, for example. Now we can use the sine function, sine, and get the spline parameter to get a value that in sine function gives to us a correct shape of this line. So can I link these to the offset? No, I have to use a combine XYZ, link the vector to the offset. Look at this red line, this is the x-axis, the output of the x sine to the x. And use what? Not the vector, okay, because if I increase the length of this line, the vector will distort our values in the sine. I want to maintain the value for each point of this line, even I increase the length. So 0.1 is always here, 0.2 always here, and etc. Even I increase the length. So I will use the length. Now you can see this is 1 meter in the z-axis. I need to increase the frequency of this shape. So to do this, I need to multiply this length by a vector and use this for the sine. And if I increase, I have more frequency. But this is too large. I have to decrease the thickness of this shape. So I can use what? This radius, because in the final result we want two lines that touch each other, and if I increase the radius I want to maintain this touching. So the axis between these two lines with the sine shape has to be the core of the thickness of this entire shape of the sine. First of all, I can select all these nodes, Ctrl G to make a group, and we can export the radius outside, rename it in the group radius from 0 to infinite. Tap to exit from the group node. This is our group node. We can export this radius outside the geometry node system. Rename radius, no, okay, it's perfect. So this is our wire. Tab to enter in the group node, and we can use after the sine, shift D to duplicate this multiply, and shift the right button drag to link this value of radius to shrink the shape of this sine. Now if I press Ctrl Alt right button drag, I mute for a moment this value. I can touch this value as I want. You have to have a base number of values that you can manipulate with a coefficient in your project. You have to try to get normalized value. So the final result wants have this shape and at the same time a shape to the other axis passing through this point, this point, this point, etc. in 3D space. So here, here, and here, etc. So we need to normalize this shape. How? I want to define a step of my whole length. So we can decrease this number a little bit. This is 1 meter, and if I decrease this value to this number, we have one entire shape of the sine, one entire period of the sine mathematical function. I want to have the half of this value, so you can notice this 6.38. It's similar to 2 multiplied by pi. We can set a pi because we want half of the period. The other line will passing through this part in the y-axis. Now we have to subdivide this shape with a frequency that we want. So I can simply duplicate this, divide by what? If I divide by 1, I have 1 piece. If I divide with 0.5, so half a meter, I have 2 pieces. So we can export this value to have the length of our holes. Press tab to exit and export these. I can move this value up and set hole length from 0 to 1 meter, for example. Tab to enter in this blue node, move up the value, hole length from 0 to 1 meter, and now tab, if I have 0.05 centimeter to have a hole like this, you can see the repeating of the shape, and this is 0.05 meter. This is the first hole. This will be the second, the third, and so on. But it's too big, the thickness of this shape, so we can unmute this link, Ctrl Alt right button, and this is the result. Next, we will have to instance this shape on a number of points with a distance from 0. So the other line will go here, and then here, and then here, etc. for example. And we want to shift this line to have this part of this curve in the exact point that there will be the other line on the y-axis. So we have to shift these, adding what we can add before the sign. We have to add a value. You can see if I add a value, we can shift before the sign value. If I enter 0, I have a 0. I have to indicate a pi value, divide by 2. And now you can see each 0.05 meter, 5 centimeter, from here to here, from here to here, etc. We have the curve, not the central point, but the end of the curve. Here, here, and here, and so on. So the other line will be here, and here, and so on. Now we can make it better. Now you can see that if I decrease the whole length, divide by 2, the resolution sucks. So we have to change this count with number of frequency that we want to export in our geometry system. So I undo this value, and we can use this count, multiply this with 100 for a initial base value, and we can export this as a wave level or wave frequency if you want. Tab, export this wave level from 1 to 10, I think. Tab to enter. The wave level is not a float value but an integer value. Now if I increase the wave level, we have more counts. The frequency level is also the factor that we can multiply to have double or 3 times or 4 times this curve to have a multiple detail of this sine shape. So we can use this x, we can multiply this value another time. So you can see these results as a success. So we can use this wave level to have this multiply, And now if I increase the frequency, I also increase the counts. So if I set 1, I have these counts, but if I increase the frequency, I added more counts to my shape. I normalize this with a proportional values. So we can move this a little bit. We can set this value here and here. Now I reset to 1 this value. So you can see this little issue. Next we will have a line from the other axis passing through this point. So if I increase the wave level, the wave frequency, I need to have in this point the same curvature, the same side of this curvature, and not this. If I set 2, you can see in the exact point of the whole length, 5 centimeter, we have the other side of the curve. I have to maintain this side. So to do this, if I set 3, you can see this is maintained. So we have 1 and 2. To have 2 of this shape, I need to have 3 in this case. So to have a correct number of frequency that let us to have always the same side, we have to do this little mathematical operation. We have to use wave level multiplied by 2 and subtract 1, and use this value with the counting, and you can see I need to use these for the multiply for the frequency, and you can see this behavior, this result. Now if I have 1, I have in this line this side of curvature. If I set 2, I have 2 multiplied by 2, 2 by 2, 4, minus 1 is 3, the number of before. If I set 3, you can see I have always the same side of this shape in this side, okay, and not in this side, and so on. So I can make it better, like so, and this is our wire line. We can increase and have 0.1 hole. You can see in the points that we have the step of the whole length, we always have the same side of the curvature. 1 is here, 2, okay, multiply by 2, subtract 1, 3, 4, 5, etc. Now I set this to 1, save your project. Now we also need to export the entire length of this line. So we can click here to direction to have the direction and the length, and export both of these information. Move it the direction up and the length up. Perfect. And this is the final result of our wire. Tab to exit from this node. This is the wire. We can rename simple wire. Now we need 2 wires. One in the, I indicate -1, for example, to go down, and 1 to go right. I can simply shift this curve and set shift the right button, the same radius and the same whole length and the same wave level. Now the direction of this line will be in the not x-axis but y-axis to intersect with this shape. So I can set 1 and 0, and you can see this line. Okay, shift Z to see the studio material. Now decrease the whole length. Now we can use a grid to let us instance these 2 lines, but we have to pay attention to this. Shift Alt click, we have the plane. We need only 2 vertices of this Shift Z to this plane. We can rotate these to the y-axis by 90 degrees, and we want to instance one line to this vertical line by some points, and the other line to this line vertically with some points. To do this, I have to delete some geometry of this plane. So first of all, export the size X and the size Y of my grid. I can move up this value. I have to delete geometry in one part I have to delete the edges of my plane, so I can use the index of my edges and compare the index, setting the integer of my index. If this is not equal to 0, I want to delete this rotated geometry. So if I Shift Alt and click, you can see it remains only the edge. So we can select these nodes, duplicate here, set Shift Alt and click. We can link the same geometry as input, but increasing the value of index, we can have this line. This is the approach that I chose for this tutorial, but you can use a different approach if you want. Now I have two lines that I can increase with these two values, size X and size Y, and now we have to instance on points some values, but before we have to resample these two lines with a number of points that we have using the whole length. Each 0.05 meter we want a line, so we can use the whole length, but we have here a count, so we have to set a length type here and link the whole length here. The same to this side, length and link length, but there is a problem. Shift Alt and click. Input geometry has unsupported type mesh, so we have to use a mesh to curve node here, okay, and here. Alt right button and Shift Alt click to have the resampled line. Now we can Alt and drag, we can have the first instance, Shift Alt and click, and this is the vertical lines. Duplicate these, link 1 and 2 to have the other instances, join it together, Shift Ctrl and drag, right button, and now we see we have to adjust some values. First of all, we have size X and Y, and we can use these to have the same length of the single simple wire. So you can use these and these. If I decrease the size of one direction, I have the correct result, and the same at the other part. So I have an issue here. I used the wrong node, so Ctrl X here and mesh to curve, Shift D and click, and we have the net. But there is a problem. You can see all lines are the same. It's not the real behavior that we want. We want to alternate, okay, the scale of these vertical lines and at the same time the horizontal. So we have to manipulate the scale of these instances using the index of each line. We have now the index of the point here. In this case, we can drag the index with a module. I remember the use of the module. If we have the value 2, each 2 index we have 0 value, and between we have a linear values that goes from 0 to 2. So we have 0 here, and increase 1 here, 1.5 here, etc. And before we have 2 value, we start again to 0 and so on. So 0, 1, 0, 1, 0, 1, etc. Now with this value we can use a map range, and we know that we want to scale, to manipulate the scale, so we have to start with a 1 value, a basic value. So from 0 to 1 value I want to have 1 and minus 1 value to the output. So we can use this result in a combine XYZ in the x-axis, so in this axis, maintain the other value to 1, it's a scale, and link the vector to the scale. And now we have the vertical lines alternate their scale. The same for the horizontal lines. So we can drag these and connect the vector to the scale. But there is a problem. We have an issue, an intersection here, here, and so on. We need to invert the scale of the x axis to avoid the collision. To do this, I add a vector math here and use a multiply, not the scale. We want to multiply by -1 the only x-axis and 1 the other axis. So here we have the correct position. There is another colliding behavior. This is caused by the size x and y of our grid that has to be increased by a step. We know the step. The step is the whole length. So we need to adjust this size x before using in this node of the grid and the length of the simple wire. We have to snap the size x with the whole length, snap, and use it at the size x. The same, duplicate, size y, whole length, and link to the size y. We have to use the same value as the length for this simple wire and this for the length of this simple wire. And now if you increase or decrease, you have a step that let us to avoid the issue. Now we can adjust a little bit the graph, and this is the final result of our graph. Now at the end you can assign a set material. We have to create a new material in the material section, metal. You can set the roughness with a low value 0.05, metallic to 1. Select the metal, show the material preview, and voila, this is the result. Go to layout, show the material preview, zoom in, and play with these values. So I can increase the size in the X and Y direction. I can increase the whole length if I want, and if I set 0.1 and increase the wavelength, we have a float number. We can go to geometry nodes and set the wave level as an integer value from 0 to 10 and set to 1 with a default number with minimum of 1. Radius, it's okay, from 0 to 0.1 meter, I think. Whole length, size X and Y, perfect. Go to layout, and now if I increase the wave, I have this magical result. No intersection, even I increase the radius. If I increase the radius, we have no collision. Save your project, and the tutorial is finished. So thank you guys for watching this video. I hope you like it. Don't forget to watch the next videos of this series. If you like it, leave a comment or check a like. For each video you'll be able to make the geometry nodes system on your own following this tutorial, or download the project from my Gumroad page, link in description. Last but not least, at the end of this series I'll add an additional link in the description of all these videos, so you'll be able to download the entire bundle of these projects always on my Gumroad page. If you like what I'm doing, please subscribe to my channel and make sure to check the bell icon to get notifications about new posted videos. See you soon in the Type 2. Bye!